On a stretch of Lake Erie shoreline called Whiskey Island, in the summer of 2024, a hydraulic shear closed its jaws around a beam of century-old steel and bit down slow, the way something tests a mouthful before it commits. What came apart under that blade had once stood 10 stories over the water. It had weighed 1.6 million pounds, 800 tons of American steel, more than the weight of a dozen fully loaded freight locomotives welded into a single skeleton. And when it worked, that skeleton closed its own jaws around 17 tons of raw iron ore at a time, over and over, 1,000 tons an hour, for the better part of a century. They called it the Hulett. Up close, in its working years, it didn't look like a crane so much as a creature. 100-foot steel neck, bending down toward a ship's open hold, a jaw of riveted iron opening and closing at the bottom of that neck, and somewhere inside its throat, riding in a glass box directly above the bite, a man. For 80 years it stood over the men who fed it, and the men who fed it stood, sometimes, close enough to touch it while it was still closing. Nobody kept a running tally of every time that arrangement almost went wrong. What got written down was simpler. The job was dangerous by design, and every man who took it knew that walking in. Then the ships that needed the Hulett stopped needing it, and a machine that once emptied a freighter's cargo hold in half a day sat down on its own rails and did not move again for 32 years. This is the story of what happens when a machine outlives its purpose, but not its danger. How something built to devour 17 tons in a single bite ended up cut apart for scrap, on the same lakefront where it once ran men ragged, trying to keep pace with it. Somewhere between 1992, when it worked its last shift, and 2024, when the shear finally finished the job, there's a question worth sitting with. Why does a beast this size get to lie half dismantled in the open for 32 years before anybody finishes what they started? 17 tons in one bite. Somewhere inside that creature, riding in its throat every single working day, was a man whose job depended on trusting a machine that could kill him without ever meaning to. Before you can understand why anyone took that job, you need to understand exactly what he was riding inside of. Here is a number that does not get easier to hold the longer you sit with it. 800 tons. That is what one Hulett unloader weighed standing idle on its rails, before its arm ever swung, before it did a single hour of work. 800 tons is heavier than the steel in 5 fully loaded jumbo jets. It is heavier than a city block of loaded freight cars, and there were once as many as 77 of these things gripping the Great Lakes shoreline at once, 14 of them in Cleveland alone, standing shoulder to shoulder like an iron regiment nobody remembers enlisting. Now here's the number that should actually worry you. 17 tons. That is what a single Hulett bucket could rip out of a ship's hold in one bite, one motion, one swing, one closing of steel jaws, in well under a minute. Do that enough times in an hour, and you've moved 1,000 tons of ore off a freighter before most office workers finish their coffee. A ship that used to sit at dock for a full week, held hostage by men with shovels, could be emptied in half a day, sometimes less. Before the Hulett, unloading an ore boat took 100 men, 12 back-breaking hours, to move 5,000 tons. After the Hulett, 4 of these machines could move 10,000 tons, double the cargo, in under 5 hours, using only 25 men. Do the arithmetic on that, and it should stop you cold. 75 workers gone from the payroll, replaced by an arm of riveted steel that never got tired, never asked for a break, and never slowed down for weather. It needed almost nobody to run it, either. 3 men. 3 men could operate a machine that outshoveled 100 human beings without breaking a sweat, because it didn't sweat. It didn't need to. Here's what nobody put on the postcard, though. Learning to run one of these machines well took roughly 5 years, long enough to learn how to read a ship's hold through a pane of glass, judge the swing of a bucket you were riding inside of, and never once misjudge how close that much moving iron was allowed to get to another human being. Because there were other human beings in there. Men climbed down into that same hold, into the dark, while the bucket kept working around them, and the docks had a name for the men who did it. That name is coming. It isn't a compliment. For now, hold on to this. A machine built to save labor still needed men standing inside the reach of its own jaws to finish the job. That detail never made it into the annual report. Here's one more, and it's the one that should really unsettle you. This machine spread fast. Within 15 years of its first successful test, more than 50 of these things stood on Great Lakes docks, and by the time the design hit its stride, roughly 80 had been built in total. Every single one of them ran on the same basic arrangement: a 17-ton jaw, a glass cab riding just above it, and men on the ground finishing whatever the jaw couldn't reach. 80 machines, 80 versions of the same bargain, repeated up and down 2 Great Lakes shorelines for the better part of a century. One more number before this chapter lets you go. 4 of these machines, working one stretch of Cleveland shoreline alone, moved an estimated 100 million tons of iron ore, coal, and limestone across 8 decades of service. 100 million tons, off of ships, onto rail cars, feeding a steel industry that built half of industrial America. Hold that number. It's going to matter again before this is over. And here's the strangest fact of all. This machine, landmarked, studied, written up in engineering journals as a marvel of its age, did not simply retire when its working life ended in 1992. Pieces of it sat exposed on that same lakefront for another 32 years, waiting on a promise nobody quite kept. That's the debt this whole script is walking toward. It's the reason this video exists. The weak, the shovel's lost. By the 1890s, the shovel was losing a war it never should have had to fight, and everybody on the Great Lakes waterfront could feel it. Iron ore was pouring down from Minnesota's Mesabi Range, a deposit so rich it seemed built to embarrass every unloading method that came before it. Ships arrived at Lake Erie ports, stuffed with thousands of tons of raw ore, and there was exactly one way to get it out: men, shovels, and time. A crew of 50 workers, under good conditions, could clear 3,000 tons off a ship in 24 hours. Under bad conditions, and on the Great Lakes late in the season, conditions were often bad. Ore froze solid in the hold. Crews resorted to 20-foot iron poles just to crack it loose, wrestling chunks the size of boulders in weather that could kill a man on its own, long before the ore ever got the chance. A ship could sit at dock for the better part of a week. Every day it sat was a day it wasn't earning anyone money, a day the shipping season, already short and already closing fast behind the ice, got shorter still. This was the enemy, a bottleneck built directly into the geography of an entire industry, with no rival company and no single person anyone could blame for it. Somebody had already tried to beat it. In 1880, an inventor named Alexander Brown rigged up a cable tramway the men nicknamed the Tom Collins, hoisting tubs of ore straight up out of a ship's hold. It worked, for a while, until the cables sagged under the weight and fouled the whole machine. Brown went back to the drawing board and built something sturdier, an iron bridge hoist with a clamshell bucket that could take a bite out of a hold on its own. For 20 years, the Brown hoist ruled the docks. But the ore kept coming faster than even Brown's machine could move it. Something had to beat that bottleneck for good. That something had a name: George Hulett, born in 1846, in the same small Ohio port town, Conneaut, where his invention would first prove itself. Hulett wasn't a career engineer. He ran a general store for 15 years before he ever touched a piece of ore-handling machinery, then spent another decade selling produce on the Cleveland docks, watching closer than most exactly how badly the shovel method was failing everyone who depended on it. He came to his invention late, near 50 years old, with no formal engineering training behind him at all. In 1898, Hulett filed a patent for a machine unlike anything the waterfront had seen, a gantry that straddled the rail tracks along the dock, carrying an arm that could reach down into a ship's hold and come back up already full. Getting it built took more than a good drawing, though, and here's where the real gamble happened. Hulett took his idea to Andrew Carnegie, by then the most powerful steel man in America. Carnegie was interested. He was not convinced. His answer amounted to this: build it, and if it works, I'll buy it. If it doesn't, you tear it down on your own dime. Nobody at the company backing Hulett, Webster, Camp, and Lane of Akron had to say yes to that deal. They said yes anyway, putting up roughly $45,000 of their own money on a machine that had never lifted a single ton of anything. A year later, in 1899, that machine stood finished on the Conneaut docks where Hulett had grown up, and Carnegie came to see it for himself, bringing along his company's president, Charles Schwab. Two of the most powerful men in American industry stood on a Lake Erie dock, watching a shy, plain-spoken inventor who reportedly talked to them the same unhurried way he'd once talked to a team of draft horses back on the farm, waiting to find out whether his machine would justify the bet or bankrupt the company that built it. It worked. The arms swung out, the bucket dropped into the hold, and came back up loaded. Dock workers watching that first demonstration didn't wait for an official name. They took one look at the bucket snapping shut around 10 tons of ore and started calling the whole contraption the clamshell, a nickname that stuck on the Conneaut waterfront long after the machine's real name won out everywhere else. Carnegie bought it. Word moved almost as fast as the ore did after that. Within a decade, Huletts dominated the docks at Conneaut, Lorain, Buffalo, Ashtabula, and Cleveland. U.S. Steel ordered a half dozen of them for a brand-new mill rising in the dunes outside Chicago. 4 of Hulett's machines could now move 10,000 tons in under 5 hours, with a crew of 25, and the Brown hoist, king of the waterfront for 20 straight years, didn't just lose a customer here and there. It lost the argument entirely. Ports that had leaned on Brown's cable and bridge design tore it out and put a Hulett in its place, almost as fast as new machines could be built. That's how completely the shovel had lost, on the strength of one nervous demonstration and a company willing to bet its own money on a produce salesman's idea. Here's the detail that made Hulett's design different from everything before it, and it's worth pausing on, because it explains everything that comes after. Every earlier unloader had depended on cables, long steel ropes straining under tension, prone to stretch and fray and sag exactly when a captain needed speed the most. Hulett threw the cable out entirely. In its place, he built a rigid walking beam, a long steel arm, hinged and counterweighted, raised and lowered by mechanical force alone. The historian John Burke would later describe the finished machine as, in his words, a massive gantry crane traveling the dockside on rails, spanning 4 rail trackways. No stretch, no sag, no sudden failure under load. Just steel moving against steel, at a speed and a certainty no rope and pulley system could ever match. That certainty is what sold it to the steel companies. It's also what would make the machine dangerous, in a very particular way, because a system with no give in it has no forgiveness built into it either. For now, all anyone on the Cleveland waterfront cared about was the arithmetic. Ships unloaded in hours instead of days. Mills fed on schedule instead of chasing a bottleneck. And a small-town inventor who'd spent his best working years selling produce instead of designing machinery had just changed the shape of an entire industry before he'd even turned 60. A machine built to never miss. Here's the question that should nag at you. How do you build something that reaches down into a moving ship, grabs 17 tons of loose rock with total precision, and does it again and again for 80 years without the whole system tearing itself apart? The answer starts with geometry. High above the water, a Hulett straddled 4 sets of railroad track on massive wheeled trucks, steel legs strong enough to carry the machine's own 800 tons, plus everything it lifted. Riding on top of those legs sat a pair of long girders, stretching well over 100 feet, from the dock face out over the water and back over the rail yard behind it. A carriage rode along those girders, free to travel forward toward the ship or backward toward the stockpile. And hanging from that carriage was the walking beam, tilting up and down like a lever finding its balance point. At the water end of that beam hung the part that did the actual violence, a vertical leg, dropping straight down, with the bucket fixed to its base. Open. The bucket could spread 18 feet wide. Closed and loaded, it carried as much ore as a full freight car. But could the machine actually see what it was grabbing? That was the real engineering problem, and Hulett's answer to it was almost unsettling in how literally he solved it. He put a man inside the leg. Directly above the bucket, built into the vertical column itself, sat a small glassed-in cab. An operator rode inside that cab on every single cycle, down into the darkness of the hold, eye level with a bucket full of raw ore, then back up into daylight, then down again. A writer for National Geographic, watching the machine work in 1907, put it plainly. The walking beam oscillates up and down, carrying the bucket down into the hold. Simple words for something that, watched up close, looked less like machinery and more like a living thing taking a breath and diving. That cab is the whole design in miniature. Every earlier unloader had tried to solve the reach and grab problem with distance, operators standing safely on the dock, working levers from far away, guessing at what the bucket was actually doing below. Hulett refused the guess. He put his operator's body inside the mechanism, close enough to feel every shudder of the load, because precision at this scale couldn't be managed from a distance. It had to be managed from inside. That decision built something remarkable. It also built something merciless, and there was no separating the two. Consider what the machine actually had to survive to keep working. A ship's hold is not a stable platform. It shifts as cargo comes off, sometimes by inches, sometimes hard, as the vessel's balance changes with every scoop the Hulett took. The bucket had to find its mark inside a moving target, in low light, packed with ore that could be loose gravel 1 hour and frozen solid the next, after a hard winter freeze. A telescoping motion in the leg let the bucket extend and swing to reach the next hatch over, without repositioning the whole machine. A flexibility that let the arm reach almost anywhere it needed to inside a hold. That flexibility wasn't a luxury. It was survival. A machine that couldn't adapt to a shifting, freezing, uneven cargo hold would have jammed, or stalled, or worse, on its very first shift. Freighters weren't built with the Hulett in mind at first, either. Cargo hatches on a lake boat were spaced to suit the ship, not the machine unloading it. And a bucket with no reach to spare would have needed the Hulett to reposition its entire 800-ton bulk for every single hatch on every single hold. Instead, the telescoping leg let the arm swing and extend far enough to cover one hatch, then the next, without the machine itself ever having to move. Over time, that same flexibility ran the other direction too. Once shipbuilders understood exactly what a Hulett could reach, they started spacing hatches farther apart, confident the machine could still find them. The unloader didn't just adapt to the ships on the lake. Eventually, it started shaping how new ones got built. Picture the whole thing in numbers you can actually hold. 800 tons of machine, 1.6 million pounds, is roughly the weight of 5 fully loaded jumbo jets sitting wingtip to wingtip on a single dock. Now imagine that entire weight balanced on rails, in motion above open water, with a man riding inside its lowest, most exposed point. That was an ordinary Tuesday for a Hulett operator. The machine could move 1,000 tons of ore an hour once it hit its stride, enough to fill more than 6 modern dump trucks every single minute, hour after hour, through Lake Erie winters that froze spray onto the girders, and summers thick enough with dust to cut visibility inside that glass cab down to almost nothing. And when the hold finally ran low, when there wasn't enough loose ore left for the bucket to grab cleanly on its own, the machine hit its hard limit. Steel and hydraulics could dig, lift, and dump. They could not sweep a floor clean. For that last stretch of every unloading job, something had to go into the hold that wasn't made of iron. That something was a man. The docks had a name for him, and the reasons the name stuck belong in the next chapter, not this one. The men they called Ore Hogs. They called them Ore Hogs, and if you ever wondered whether the nickname was affectionate, it wasn't built that way. It was built the way most dock nicknames were built, blunt and dead accurate. An Ore Hog's job began exactly where the Huletts' mechanical reach ended. Once the bucket had scraped up everything it could grab cleanly, there was still ore left, pooled in corners, packed against bulkheads, scattered in a layer too thin and too uneven for the machine's steel jaws to bite cleanly. Somebody had to finish the job by hand. That somebody climbed down into a cargo hold that had just spent hours getting torn open by a machine the size of a 10-story building, and started shoveling the leftovers into position so the bucket could take one more pass. The bucket did not stop working while they did this. Picture the geometry, because it matters. A man stands in the bottom of a dark, enclosed steel hold. Above him, a 17-ton bucket is descending, the same bucket that just tore through the bulk of the ship's cargo in a single motion, reaching now for the pile he is actively shoveling toward it. There is no wall between the man and the machine. There is no separate chamber, no safety cage, no pause button. There is only timing, trust, and an operator riding a glass cab directly above the bucket, watching through the same window that let him judge the ore, trying to judge the man too. This arrangement wasn't rare, and it wasn't occasional. It was the standard method for finishing a hold, repeated on every ship, every season, for more than half a century, on Great Lakes docks up and down Lake Erie. Men worked inside the reach of a 17-ton machine because the machine, brilliant as it was, could not finish its own job alone. How does a system like that not end in catastrophe on its first attempt? The honest answer is precision, brutal and hard-won. It took roughly 5 years to fully train a Hulett bucket operator. 5 years of learning exactly how far the bucket could swing before it crossed from close to catastrophic. 5 years of reading a hold through dust and dim light and judging, correctly, every single time how much clearance a man's body actually needed. There was no partial credit in that training. There was only right and everything that wasn't. For decades, this was the arrangement nobody outside the industry thought much about. It didn't make headlines the way a collapse or an explosion would have. It was quieter than that. A daily risk absorbed into the routine, carried by men whose names mostly never left the timesheet. The danger wasn't one dramatic failure. It was the machine's whole operating model, a 17-ton bucket, a human body, and a shared few feet of space, repeated on every hold, on every ship, for as long as the Hulett worked the docks. It's 2 in the morning on a Cleveland freighter. Ore dust hangs thick enough to taste, and cold comes up off the lake through the hull, straight through your boots. Your shovel keeps striking rock that won't move, half frozen from a week crossing open water, and every few minutes the whole hold shudders as the bucket lands somewhere behind you and hauls another bite of ore back up into the dark. You can't see the operator from down here. You can only hear the beam groaning overhead and feel the pile shift under your feet as tons of ore rearrange themselves around you. You're standing where the bucket's last pass left a ragged mound against the bulkhead, and somewhere above you, in a lit box you can't quite see into, a man you're trusting with your life is about to bring 17 tons down toward exactly where you're standing, because that's where the ore is, and that's the job. There's a quieter image worth sitting with too, before this story keeps moving. A shift change on Whiskey Island, early morning, before the season's rush really hits. Frost on the rails. A Hulett standing still for once, its bucket resting just above the dock. steam curling faintly off a nearby locomotive. An operator climbs the ladder into his cab, stamps the cold out of his boots, and checks the glass for frost before the first ship of the day pulls alongside. None of the men on that dock that morning had any idea their machine would spend its final decades sitting idle instead of working, pieces of it exposed in the open air for longer than most of them would ever spend on the job. That arrangement held for more than half a century. It didn't end because of a single dramatic accident. It ended because, sometime around 1953, the industry finally admitted what it had never said out loud. It didn't have to be this way. Historic photographs from the Cleveland ore docks, later archived by federal engineering surveyors, are captioned to note that before that point, it was men with shovels who did that final cleanup by hand. After it, wheeled tractor scrapers, chained to the Huletts' own bucket, took over the job instead. Steel finally replaced men in the last, most dangerous stretch of the hold. Nobody wrote a triumphant press release about it. There was no ribbon cutting for the day machines finally did the part of the job that had quietly asked men to gamble with their bodies for half a century. It just happened, gradually, dock by dock, as the technology caught up to a problem the industry had always known was there. The Hulett didn't operate in isolation either. It sat inside an entire waterfront culture that had already learned, the hard way, how dangerous ore handling could be. Up on the Great Lakes Iron Range's ore trimmers, the men who balanced a ship's load as ore poured down loading chutes had spent decades fighting for safer conditions, becoming one of the very first labor groups on the upper lakes to organize. The Ore Hogs working a Hulett's hold weren't part of that same fight and weren't doing the same job, but they came from the same world, an industry that moved millions of tons of rock every season and had, again and again, treated the men doing the moving as the most replaceable part of the system, right up until it wasn't. Somewhere in that gap, George Hulett had already stepped away from his own creation. By 1917, he was easing out of the company built on his patents. By 1918, he was gone from its board entirely. The man who solved the shovel problem never stuck around long enough to solve the ore hog problem. That one, the industry solved without him, 3 decades after he'd first walked away. Ordinary days on that dock lasted for 80 years. Then, almost overnight, they stopped, because somewhere else on the Great Lakes, somebody had built a ship that didn't need the Hulett at all. The ship that didn't need them anymore. Here's a kind of ending nobody warns you about. Not fire, not collapse, not a single catastrophic failure, just a competitor that made you unnecessary, one contract at a time. By the late 1970s, a new kind of Great Lakes freighter had started appearing at the same docks the Huletts had ruled for most of a century. These ships carried their own conveyor booms, their own unloading systems built directly into the hull. A self-unloader didn't need a dockside machine at all. It didn't need an ore hog climbing into its hold. It didn't need an ore hog climbing into its hold. It pulled up to any dock with enough water depth, swung out its own boom, and emptied itself. The math that had once made the Hulett unbeatable now worked brutally against it. By 1992, 61 of the 66 ore carriers running on the American side of the lakes were self-unloaders. The machine that had reduced unloading crews from 100 men to 25 had itself been reduced to a rounding error. A shipping company running a self-unloader paid for none of a Hulett's maintenance, none of its aging electrical systems, none of its increasingly hard-to-source replacement parts. Every ton that arrived on a self-unloading hull was a ton the Hulett never got to touch. Conrail, which had inherited the Whiskey Island Huletts from the Pennsylvania Railroad, watched that math tip further every season. 800 tons of electrically driven steel, exposed to Lake Erie winters for the better part of a century, needed constant attention just to keep running. Attention that made less and less financial sense against ships that required none of it. The end, when it came, arrived without ceremony. On December 18, 1992, the freighter Lemoyne sat alongside Cleveland's C&P dock, its holds full of Mesabi taconite pellets, while the last working Hulett on that stretch of shoreline went through motions it had performed 100,000 times before. Bucket down, 17 tons up. Swing, dump, swing again. Late December cold off the lake, the same cold that had bitten through Ore Hogs' boots for 80 winters, cut across a dock that was, by then, mostly empty of the crowds that once worked it. Nobody on shift that day had reason to think it was any different from the 10,000 shifts before it. Then the last hopper emptied, the bucket lifted clear for the final time, and the Lemoyne pulled away, relieved of its cargo. It was the last ship a Cleveland Hulett would ever unload. No headlines marked the moment. No crowd gathered on the dock. A machine that had once outworked 100 men without breaking stride simply finished its shift like any other, and then never worked again. 4 Huletts stood silent on Whiskey Island after that. And almost immediately, a fight broke out over their fate, one that would drag on far longer than anyone expected, and end far worse than anyone hoped. Preservationists moved fast. Within a year, the city of Cleveland granted the Huletts landmark status. By 1997, they'd earned a spot on the National Register of Historic Places. In 1998, the American Society of Mechanical Engineers went further still, naming them a historic mechanical engineering landmark, an honor that placed these idle steel giants alongside some of the most significant machines in American industrial history. A landmark plaque, though, doesn't move 800 tons of steel off a working dock, and it doesn't pay to keep it standing either. So what actually happens when a piece of certified American history runs straight into a port authority that just wants its land back? None of it mattered to the calendar the way anyone hoped it would. The Cleveland-Cuyahoga County Port Authority and the companies that owned the land underneath the Huletts wanted the space back. Landmark status doesn't pay dock workers, and it doesn't create berthing room for modern cargo ships. Historians, mechanical engineers, retired steelworkers, and park officials all found themselves on the same side of an argument they never expected to be having, pushing back against a port authority that simply wanted its dock space returned to active use. It was, by most accounts, an odd coalition, united by nothing except a shared refusal to watch the machines disappear without a fight. By the late 1990s, the standoff between historic preservation and hard economics had reached the only place standoffs like that usually end up, a compromise nobody was fully happy with. In 1999, the two sides finally struck a deal. 2 of the 4 Huletts would be sold outright for scrap, gone for good. The other 2 would be carefully dismantled, not destroyed, dismantled, broken down into their major components, and set aside on Whiskey Island itself, with the promise that someday they'd be reassembled and put on public display. That promise was made in 1999. It would take 25 years for anyone to learn exactly what that promise was worth. For a while, it looked like the story might end well. Preservation groups like the Ohio Canal Corridor and Friends of the Huletts kept fighting for full restoration, kept pushing for funding, kept the machines in the public conversation even as they sat disassembled, gathering rust on the same dock where they'd once ruled. Engineers floated proposals. Historians wrote articles. A minor uproar erupted in 1998 when word got out that the Port Authority had considered scrapping all 4 Huletts outright, loud enough that at least 2 machines survived it, even in pieces. But surviving in pieces is not the same as surviving. A disassembled machine generates no revenue and requires no crew. It just sits. And sitting, on an active industrial waterfront where every square foot of dock space carries a dollar value, is its own kind of slow death. Year after year, the reassembly project everyone had promised in 1999 failed to materialize. The obstacles were the same ones that kill most ambitious preservation projects: cost, and where exactly do you put something this size? Relocating and rebuilding 2 multi-hundred-ton steel structures wasn't a weekend project. It needed a site, a budget nobody had fully committed to, and political will that kept arriving in short supply exactly when it was needed most. So the pieces stayed where they'd been laid down. Through the 2000s, through the 2010s, through a full generation of dockworkers who'd never seen a Hulett actually move, who only knew the machines as rusting geometry behind a chain-link fence at the edge of the bulk terminal. By 2024, the Port of Cleveland had run out of patience. They'd been sitting on the bulk terminal for 25 years, the port's president said flatly, announcing the decision everyone had been dreading and half expecting for a decade. The port needed the space for modern cargo handling. A promise kept alive on paper for a quarter-century was finally, officially, over. 25 years of waiting were about to end, the only way waiting like that usually does, with a shear, a crew, and an ending nobody had actually pictured back in 1999. Where the beast still lies in pieces. Here's the payoff to everything this script has been building toward. The calendar finally forced an ending nobody on Whiskey Island had actually fought for. In the summer of 2024, Northern Ohio Scrap Services won the contract to finish what had been left unfinished on Whiskey Island for a quarter-century. The company brought in a Genesis hydraulic shear, mounted on a heavy excavator, and went to work on what remained of the two disassembled Huletts, the ones that were supposed to have been reassembled and put on public display as monuments to an industry that no longer worked the way it once had. Martin Rosenberg ran the dismantling effort. His family's company had processed plenty of industrial history before, but this job was different, and he knew it walking onto the site. What had looked, for 25 years, like a tidy stack of dismantled parts turned out, up close, to be its own sprawling puzzle. There were other separate components on site which had to be dealt with, Rosenberg would say afterward, describing a job that involved far more than simply cutting up two big machines. Every beam, every plate, every fitting that had been carefully set aside back in 1999 now had to be identified, sorted, and reduced, one purpose-built shear bite at a time, before the site could finally be handed back to the port. Instead, piece by piece, the machines that were meant to rise again became scrap. Each Hulett, broken down into its major components, turned out to be even more massive up close than the 800-ton headline number suggested. The gantry alone, the steel undercarriage that let the whole machine ride the rails, weighed 480 tons on its own. The trolley that carried the walking beam back and forth weighed 150 tons. The walking beam itself weighed another 150. A tailpiece added 25 tons. A boom brace added 25 more. And the bucket arm, the very component that once reached down into a ship's hold and came back up heavy with 17 tons of ore, weighed 50 tons entirely on its own, even empty, even silent, even after 32 years of doing nothing at all. Cutting through steel built to survive a century of Lake Erie winters wasn't fast work. It took a purpose-built hydraulic shear, biting through beams engineered to never fail under load. The Hulett spent its working life being merciless to the ore it processed, and indirectly to the men who fed it. In its final year, something finally had to be just as merciless back. Whiskey Island wasn't the only place a Hulett story ended, though, and not every ending looked the same. Some pieces of this machine, it turns out, never made it to the scrapyard at all. A grab bucket and an operator's booth from one of Ashtabula's own Huletts, scrapped decades earlier in the early 1980s, survive today as a static display, roughly 18 feet of the original structure, preserved as a reminder of what once worked that stretch of shoreline. Farther east in Conneaut, where George Hulett's very first machine proved itself back in 1899, pieces of that history exist too, though not comfortably. Accessory parts and original documents from the Conneaut Huletts sit safely inside the Conneaut Area Historical Museum today. At least one piece of the machine itself, though, has spent recent years still resting outside, exposed to the same lakefront weather that has been wearing it down for decades, waiting on funding that hasn't yet arrived to bring it in out of the elements. That's the quiet, unglamorous truth about industrial memory. It gets preserved when somebody has the money and the will at the exact right moment, and it gets lost everywhere that alignment doesn't happen to line up. Cleveland almost got there. For 25 years, it genuinely looked like maybe, eventually, it would. Then it didn't. George Hulett never saw any of this. He died on January 17, 1923, 69 years before the last Cleveland Hulett would ever unload another ship, and a full century before a shear finally cut apart the machine that carried his name. He spent his last working years easing away from the company that built his invention, watching from a distance as Wellman Seaver Morgan carried his design further than he ever personally would. He never saw a Hulett stand idle. He never saw Whiskey Island's fight over landmark status, never saw the 1999 compromise, never saw pieces of his machine sit through 25 Lake Erie winters, waiting on a promise that quietly expired. In a strange way, that might have been the mercy of a life cut short by ordinary old age, rather than disappointment. He got to know his invention only as a triumph, never as a stalled, rusting argument over whose job it was to finish what preservation had started. What the Hulett actually accomplished, in its working years, is hard to overstate. At the Whiskey Island docks alone, 4 machines moved an estimated 100 million tons of material across 8 decades of service. Looking at the broader Hulett era across every Great Lakes port that ever used one, historians researching the industry have put the total even higher, into the billions of tons of iron ore moved off freighters and onto the rail cars and stockpiles that fed America's steel industry through 2 world wars and a century of industrial growth. Cleveland became one of the great steel cities of the 20th century, in no small part because a former produce salesman figured out how to make 17 tons disappear from a ship's hold in less time than it takes to read this sentence. The basic idea Hulett proved out on that Conneaut dock in 1899, a rigid mechanical arm reaching down to grab bulk material with total repeatable precision, didn't disappear when the last Hulett went quiet. It just moved on to other machines, other docks, other industries entirely, in every grab bucket crane and bulk handling rig that came after it. The specific design died. The idea underneath it never really did. And still, when the technology it had beaten got beaten in turn, when self-unloading ships made the Hulett's speed and precision irrelevant almost overnight, the machine didn't get a graceful exit. It got 32 years of standing still, half of them spent literally in pieces, before anyone finished the job the industry itself had started back in 1992. So if you're ever on Whiskey Island, on that stretch of Lake Erie waterfront where 14 of these giants once stood shoulder to shoulder, look for what's left. It isn't much. Open dock space, cleared now for modern cargo handling. Maybe, if you know exactly where to look, a few traces of rail track that used to carry 800 tons of moving steel back and forth, feeding an industry that doesn't run this way anymore. The men who ran these machines are mostly gone now too. The Ore Hogs, the 5-year apprentices, the operators who rode a glass cab down into a dark hold 1,000 times a season and never once let 17 tons close on the wrong thing. Nobody wrote most of their names down anywhere that lasted. The machine outlasted almost all of them in public memory. Right up until the summer, a shear finally caught up to it as well. 80 years of work, 32 years of standing still, and in the end, not even 800 tons of steel gets to rot in peace forever.